Okay, hi guys. So in this lecture, we'll be discussing the efficiency of the heat engine or the Carnot cycle. So let's get started. So we'll be discussing efficiency of heat engine or Carnot cycle. Okay. So efficiency can be written as net work done by the system divided by heat absorbed by the system. Okay. So this can be written as Q net divided by Q system as well. Okay. So work done by the system is Q1 plus Q2 and heat absorbed by the system is Q2 from the graph which we saw in the previous lecture. So Q1 plus Q2 can be written as NR T2 minus T1 T2 minus T1 ln V2 upon V1. This is just the negative of the work done divided by NR T2 ln V2 upon V1 would be the Q2. Okay. So neta would be equals to simply T2 minus T1 divided by T2. Okay, which is also the ratio of Q1 plus Q2 divided by Q2. Okay. So this can be written as minus of work done total divided by Q2 as well. Q1 plus Q2 can be written as minus of W total, which is equal to T2 minus T1 upon T2. Okay, so from here we can write that as Q1 plus Q2 upon Q2 is equals to T2 minus T1 upon T2. So from here we can write that 1 plus Q1 upon Q2 can be written as 1 minus T1 upon T2. 1 and 1 get cancelled out. So we can write that Q1 upon, from here U1 upon Q2 would be equals to T1 upon T2. So this is minus sign here. So Q1 upon T1 plus Q2 upon T2 would be 0. Okay, from this equation we can write this. Okay, or we can write that sigma of dq reversible by T is 0. Okay, and similarly closed integral of dq reversible by T is 0, and dq reversible by T can be written as closed integral of ds, which can be written as 0. And this should be the case because entropy is a state function. Okay, and as ds is equals to dq reversible by temperature. Okay, and we can also write that neta for irreversible Carnot cycle would be actually lesser than efficiency of reversible Carnot cycle. So in other words, we can write that what is the eta of irreversibility. So it can be Q1 upon Q2 divided by Q2, and this should be less than efficiency of the reversible Carnot cycle or heat engine, which is T2 minus T1 divided by T2. So if we simplify this, we get that 1 plus Q1 upon Q2 would be less than 1 minus T1 upon T2. So again, Q1 upon Q2 would be less than minus of T1 upon T2. So from here we can write that Q1 upon T1 would be lesser than minus Q2 upon T2. So this can be written as Q1 upon T1 Q1 upon T1 plus Q2 upon T2 would be less than 0. Okay. So in this case, sigma of dq reversible, rather dq irreversible by temperature, would be less than 0. Okay. So the work done by the system is maximum in reversible process. Work done by a system is maximum in reversible process. Okay. Or we can write dq irreversible by temperature was less than 0. So we already know that dq by t should be less than equals to 0. This is equals to for reversible process, as we already saw, and this should be less than for irreversible process. Okay. So with this we come to the end of this lecture. In the next lecture we'll be seeing what happens in case of a non-cyclic process. So till then, good luck and goodbye.